Well, hi, and welcome to my shop. Thanks so much for joining me here today. It's January 9th. It's been a couple of days since I posted a video, but not for lack of work and effort in here. I've done nothing to this scope since the last video. But what I have done is I've done a lot with all of my test leads, which are scattered on my bench here. I did make a video yesterday, but I chose not to post it because in the end I think all it shows is something very simple happening, and I think it would be very uninteresting to watch the whole thing and then say, oh, not a lot happened there. I mean, that does happen in some of my videos. So I'm going to talk just a wee bit about what this is all about, and then I'm going to get busy on the scope and try to get it back in shape today and be done with it, because the radios are coming. So what about all these test leads? Look, I've got all sorts here. I've got everything from the simplest kind of test lead you could have to some of the best test leads you could have. This one here. I have two old vintage leads. This one is from 1960, well, I don't know, 63 or somewhere around there. I have another really old one laying around here somewhere. Goodness knows where it is. I underestimated these two test leads, that's for sure. What I didn't realize, even though I have fiddled with them a bit, is they can be compensated by releasing this lock and then turning this collar, which I know I just unset this. I have them all set and I've just unset this one. So that's actually a very, very good test lead. I have a couple like this. These were given to me by a kind individual, an American on the west coast of the United States, who also sent me up this oscilloscope. Very kind of him. Well, unfortunately, what I discovered in all my testing is this test lead, which is now tied in a knot, is defective. And it's a simple defect, it's the usual. I'm pretty sure the shield is broken on the wire in here. And it's making a, sometimes contact, sometimes half contact, sometimes no contact. That's too bad. So this guy's got to go away. Surprisingly enough, I discovered that, this really just surprised me. This extremely simple lead, which cannot be adjusted or compensated in any way, it actually works quite well. And how do I know this? I've been checking it just using the square wave that's available on this scope and my other scope up here. And just by adjusting it based on the square wave, turns out this one works really well. And that's a good thing because I have used this kind of cheap lead a lot on my oscilloscope, to some degree because these clips are so handy. Running the risk that in fact the lead capacitance is ruining the test. Not the case. These ones, not so good. And I also have two of these very, very inexpensive scope leads I purchased off of eBay, and they came from China. All one manufacturer probably, because they all look identical. I think you can still get these very, very inexpensive. What I didn't realize was there was an adjustment here. When I got these at a glance, I thought this was just a locking set screw to hold the end together. No. But the other good thing is these are not far out of adjustment at all. Once I get going on the scope, I'll put these through the test a little bit so you can see how they're done, in case you're not familiar with this. Now, in my life, yes, I was taught about this stuff in college, making sure that your test leads are matching your device, but it was a very minor part of what I learned, and my own experience was it didn't really matter. I'm doing most of my work at fairly low frequencies, but more recently I've become concerned about how I'm terminating the output from this signal generator, and most recently became concerned, as you saw in the last video, about these test leads and their proper adjustment. And I'm talking too much, so okay, no more talk. So there's a number of potentiometers in this device, like here, that are obviously scratchy because the display jiggles and jumps around as I turn them. So I'm just going to put a little bit of cleaner in these. These are all open. Open where the terminals come out from the shell. Now, so I'd like to get gravity working to my benefit here. I've got to unplug this before I. This one's, the opening is up the other way. I'm going to flip over the oscilloscope here. Okay, now there's two potentiometers that are recessed back here. There's long shafts on them. These two. And the front comes out here. These are balance adjustment controls. The way they're installed, to get gravity working for me, I'd have to do the impossible. So I'm gonna just spray a little in here. I don't know that these controls are dirty. I'm going to hope some of that runs down. I'm going to turn these. Setting the balance here is something that needs to be done with some regularity, and it's way out on the scope. Has to be done regular enough. They've put the adjustments right on the front of the oscilloscope, and that's pretty common. So it looks like the trigger level has to be done the other way around. Of snap switches here, and none of these I think are giving trouble. It's all these guys here. So until I see some trouble with the snap switches, I think I'm going to leave those alone for now. Okay, so I've soldered back the wire. Let's give it a go and we'll see if that helped. Okay, vertical position. Okay, it's moving nice and smoothly now. A little out of focus because I done every control. Okay, there we go. Just turn the brightness down a wee bit. Speed it up so it's not flickering so much. Yeah, look at that. Where's this one? Where's the other channel? What'd I do? Oh, still has dirt in it. Need another little spray in that one. Let's check these switches. Yeah. They are definitely dirty. That's not going to show up. Hard to tell, looks fine. Seems to operate fine. Can't tell with that one. That's lovely. That actually got a little bit better just from using it. Okay, this guy. Now the scope is charged up, the picture tube is charged up, the CRT. Be a little more careful from here on in. Okay, we got to turn this thing right around. Wrong way here. So just notice what I'm doing here. I'm grabbing the back corner of the scope right here, and the power cord, and the power is right here. I've got it plugged in. Shame. You know, along with getting a shock, which isn't a good thing. If you get a shock while you're holding something up in the air, probably something bad is going to follow. Okay, so the controller after is this one. Oh, I was wrong about that. Okay, that's all the easy stuff. I did want to fix these snap switches, or clean them rather. Let's take a look at where they are. So they're in a can here. A little tough to see. They're in here. This one's not too hard to get at, but the other one's much worse. Okay, I'll give those a shot. Let's see what happens. This is more of a kind of a general spray situation here. Okay, this guy didn't matter. This is the other one that I've got to get to. spot. There. Okay, don't know how effective that was. Now, I'm going to stop for a little while, reread the manual again, and figure out which one of these adjustments is worthy of attention. I should pay some attention to, which ones I should leave alone, and the like. Okay, first on the list to adjust is the astigmatism. And astigmatism adjustment is here. It'll be right there. It says right on it here R332, and that's what this is, R332. So we want to adjust that. Now, I don't think offhand there's anything terribly wrong with the astigmatism, but let's give it a go. Okay, maybe a little bit of camera overkill here, but I have two cameras now looking right at the screen. This one's a little further back. This one's almost right up against the screen. Here, have a look at that. So now there's issues with the camera focus. So I'm trying to focus the dot on here, but the camera focus itself is a bit of an issue. So let's just go through the different camera shots. So that's the sort of full screen shot, and then the super close up shot looks like this. I'm trying not to get a shock while I do this. See if we can make that less of a vertical bar. There. Back just a wee bit. What I'm thinking is focus alone. That was the focus control doing that. It should really just make a dot go in and out of focus. You shouldn't see lines. I'm thinking that. Let me try and get rid of that vertical line with the astigmatism again. Okay, now we'll focus. Ooh, what was that bright thing that happened there? You still see it going in a sort of vertical line, horizontal line shape. Try a little more. Getting my screwdriver in. Okay, here we go. Okay, it's more of a circle there. So there's still a bit of a verticalness to it here, but not too much. Let's go a little further, because this seems to be working. So I guess what I'm saying is if you adjust the focus and you go from a vertical line to a horizontal line while you're adjusting the focus, that's a sign that the astigmatism is not correct. Okay, that's focus. Focus. Focus back and see that vertical bit. Oh, wrong way. That's pretty good now. That's the focus adjustment I'm turning. I don't see distinct lines showing up. Okay, let's turn up the brightness a wee bit. That's by normal like use. That's a very it's not very bright. Okay, and we'll fool with the focus a bit. No, I can't do any more than that. but it's a circle all the time. I think that's it. I think that's the trick. At least for this scope. The blue dot down at the bottom, by the way, is the reflection of the on light on the camera. It's just the camera light itself. There we go. Now let's take a look up in a corner here. I'm going to have to manually operate the camera here. So first I'm going to move the dot. So we didn't really do it in the center of the screen, but I'm way over to the left now. Okay, and I'll move the camera there myself. The focus deal is going to be tough. Well, now it's clearly, well, I don't know. Don't laugh. So focus. So there's that line effect on the one way this way. Let's go up. Then I'm really splitting hairs here. Go up, up, up to the top corner here. Okay, focus. We're back to getting a vertical and a bit of a horizontal. Let's go right in the middle of the screen, which is probably the better place to be doing this. Okay, get it off the graticule a little bit. Oops, not that way. You notice I've straightened out the CRT also, so it's no longer on a slope. Okay, focus. Bit of vertical. Okay, let me see if I can astigmatize that vertical out of there. I'm gonna try to fix the camera back on the oscilloscope here. Okay. Okay, this is the astigmatism. Wait a minute. It's pretty dark in my shop, so there we go. Yeah, that certainly circled it up. Okay, focus. Now you're supposed to do this adjustment with altering the brightness. This is the focus. Astigmatism. Try to get the smallest dot you can get. That's the focus. I can't imagine it's going to get any better than that. Okay, so we're looking at the manual here. We just finished the astigmatism adjustment. I should have read through this again because later on it says readjust the astigmatism down here. So all that work might have been for nothing, but anyway, geometry. The trace rotation is rotating the CRT. I've already done that. The geometry. Geometry. What are we trying to do here? Set the Y shift to off position. Y1 input switch to AC trigger selector to Y1 and apply to Y1 input socket a 1 kHz sine wave set to give approximately 8 centimeters of Y deflection. Set the time per centimeter switch and level control so that approximately 10 cycles are displayed. So use the level control so that approximately 10 cycles are displayed. Adjust R333 geometry adjustment for a compromise between the horizontal and vertical pin cushioning and barreling effects. Reset the focus if necessary. Geometry. So I think what we're doing here is we're adjusting the voltages on the elements of the electron gun. It's really what we're up to. And that's why it would knock out the focus potentially again. Just look ahead a little bit. DC balance, time base, Y amp. So I think probably this is the only one that's going to affect the focus again, the geometry. Okay, so let me get this set up so we have the right signal on the screen, and then I better find out where this adjustment is, and then we'll deal with that. Okay, what was it again? The adjustment is R333 geometry. Okay, R333 geometry. R333 geometry, so it's just right beside, not surprising, it's right beside the astigmatism adjustment. And that's easily accessed. I wanted to make sure it was. Okay, I'm going to get that set up and we'll do it. Okay, so I have on the scope what it is the manual is requesting. Basically, fill the screen with a sine wave is what they're suggesting. And then use that to identify any effects which were called pincushion effects and barrel effects. Let's take a look at what that really means here. So here we are. Pincushion effect and barrel distortion. Okay, so barrel looks like a barrel. Pincushion, I don't know if that looks like a pincushion to me, but we see what they're talking about. So it's really getting these lines straight, these edge lines perfectly straight across here. That would do it. I don't think I can see this with the display that they're recommending. Let's take a look at that again. Okay, so I'm going to switch to a different camera here. The one you see. How can you recognize distortion with that? One thing I do notice is on the extreme left and right, the image is slightly out of focus. Let's try adjusting the focus here a little bit. This makes perfect sense to me that you cannot focus this thing all the way across, because we have a beam coming from a central point in the electron gun, and it's casting across a flat surface. Well, it's different distances from here to the electron gun is a different distance than from here to the electron gun, and I think that's going to forever limit the focus. I was sweating way too much over the astigmatism and that. Now, as for barrel effects, again, we're looking through a camera. The camera itself has distortions. With this like this, I don't see anything. It could be these outside lines that are curving inwards. Very outside ones. You know what? I think you could use a better display. For instance, what if we try a square wave here? Okay, we can't see the rise on it. If I turn the brightness up, can we see it? No, the rise is way too fast for this oscilloscope. On that. So I'm trying to fill the screen with straight lines and see if they're straight. So over here it's much less than one division. And over on this side here, it's also less than one division. Let's just check in the middle again. It's bang on here, and pretty much bang on there. Can you see the problem over here? Looks pretty good in here too. It's just this last one. It's definitely crunched a little bit. Would that be pin cushioning? So the adjustment clearly operates in the fringes of the screen. So I'm going to adjust that and try to stretch this out to exactly 1, thinking that it's not going to stretch it in the middle much at all. That's my scam. Okay, now how am I going to do this? So I'm going to move the camera so it's looking more at one of these edges straight on. Okay, starting getting some funny angles on the camera, but that won't hurt. We'll move the image to the right. Yeah, see how short it is now? You're looking without parallax. I'm going to try to stretch that by turning the geometry setting R333. just rotating the whole scope around. Uh-oh, that pulled the camera cord there. Okay, I'm making sure I'm getting in the right adjustment. It's the inboard one. Get my screwdriver in place. It's just a little too dark in here. Okay, screwdriver's in, camera still aimed. Here we go, turning the control now. Shrinking it. Oh, look at the focus go. Did I really expand it? I think it did. It's moving it. You know, it's expanding the whole thing. Just, you don't see the expansion in the middle. Is it like a expanding universe here? So if we expand this out where it should be, that's the limit of the control there. Wow. Okay, back with the focus. Okay. Well, the focus is at its limit. Yikes. Yikes. Now let me look at this with my own eyeballs. Oh, it's terrible. You can really see the curve in it now. Oh, you can see it in the camera too. That's a bad move there. Now it's definitely pin cushioned. It's curving like this. It's quite clear that it's doing that. Why wouldn't you set it up for a vertical line and then move the vertical line over? Well, why wouldn't this be done that way? Why wouldn't this be done that way? Let's get a vertical line to do this. And hello, trigger. Where'd you go? The vertical line appears to have disappeared entirely. I've lost track of it. It's way over on the right. Oh, you can. Oh, that's great. You can just see the curve with that. If I slow this down even more, then the line is almost standing still. It bends as it gets to the end. That's really easy to see now. Okay, we'll go up one. Speed, I can slow it down with this control. So it's quite straight in the middle here. But look, it's curving a lot. Okay, that's good. I like this. Makes it a lot more easy to see objectively what's going on. Okay, I put that. Focus one out. I'm already adjusting it. Here it comes. Straight. Curving. Straight. Now the other side, you can't see the other side when a trace comes around. Okay, it's coming through here. Coming out. It was curved a bit. I adjusted it straight. Other side. I have to wait a minute. Going on, looks straight everywhere. Going out of focus in the middle, so we'll adjust the focus a little bit. It looks pretty straight. It's really the last line to look at. Okay, I'm pretty happy with that. I think that's nice and straight now. Let's see what it looks like in the camera. I suppose I could use the video to freeze the video and look at it if I really wanted to. Not bad. That looks good. Okay, happy with that. That's done. Now we can still get a pretty good. That's the focus I'm turning. looks pretty good. Okay, I think I got a better procedure than what they suggested in the book. Okay, we're going to see what's next. Okay, next thing is DC balance. We just finished this. DC balance. Set Y1, Y2 input switches to ground. Adjust the Y1 and the Y2 balance controls to eliminate X and Y trace movement when Y1 and Y2 volts per centimeter are switched from 0.2 to 5 millivolts. 0.2 to 5 millivolts. Okay, I see what they're saying. 0.2 to 5 millivolts. So, put both these to ground, wasn't that right? Put the trace speed up. So we get a line. Put it in the center. Looks way out of focus. There we are in focus. Okay, I'll put this back. There it was. Switch back to that camera. Now the idea here is to adjust this control here. I didn't show you where that is. It's these two little balance controls that are right here on the front. Okay, and we'll start with this is Y2, and I'm just switching the volts per centimeter, and see it moving downwards. So we don't want that to happen. So now I rotated these controls wildly when I cleaned them. So let's just put that back up, back up, back up. That's pretty good already. Okay, it still needs a little bit. This is the most sensitive setting here. Oop, wrong way. Up a little bit. That's all the way up. That's the least sensitive setting. That's what? 20 volts per division. That's excellent. Okay, we'll get rid of this one. Let me bring up the other one. We'll set this on. It's on 0.2, so we'll put that right in the middle. Okay, and we'll head down. Oop, this one's going up. Let me just make this really going. Let me make an adjustment here already. Okay, and then we'll make it more sensitive. Whoosh, right off. And then balance it back down. A little bit past. Because I anticipated that. It's that little honey thing happening. I'll put this right on the center. That's the DC balance I'm adjusting. Okay, now. That didn't go so well. Ooh, what's with the jump there? Yeah, you're upset, are you, Cat? Maybe there's something a little wrong with this input. I'm going to put this back up. This is 0.2. Oh, you sound like you're dying, Cat. This went right off the screen. That's the balance adjustment coming down, a little dirt in it. There's something wrong here. So that's 20 volts per division, and you can see that it's, and then all of a sudden it jumps down again. It's not supposed to do that. There's something happening here between 0.5 and 0.2 that shouldn't be happening. So where do we want to set this? Best as possible. Oh, Peanut, please. You're not dying. stay on the screen, that would be good. When DC balance gets way off, the thing will shoot off the screen. It's definitely something right here, right between these two settings, that is not right. Okay, always pulling out the real big cries. I see you there. Okay, time to go play with the cat. Looks like I can't DC balance this channel properly. Okay, next thing to do is to calibrate the time base, and that's done by adjusting R169, which is right here. R169 is right there. Very good. Now, on the display, what I've got is a 1000 hertz signal. It's set to exactly 1000 hertz on a using a signal generator and a frequency counter, so I know it's correct. And what we've got to do is make sure that these peaks are hitting these marks. Now there's a little bit of a parallax problem with the camera, but you can see it's pretty clear in the camera that this is the parallax is making it look worse than it actually is. So you can see the center one though, we've got it just about dead on. That's me moving it there. Okay, just using the position control. So we get it dead on the center. There we go. I'm going to swing the camera over a bit so we're looking straight on over here. You can see it there. You can see that it's not staying lined up. In fact, it's particularly, well, again, parallax is making it look different than it really is. If you look dead on all the way across, it's just getting a little worse every time. So what I got to do is adjust the R to bring this up. And I'm checking again to make sure I'm doing the right one, which I am. There we go. There we are. That's simple. Now just go back along here as best I can. Set it right up on the center. It's no longer on the center. Let's center this up. Okay, you're just going to have to rely on what I say because I'm lining myself up for no parallax error. Okay, so this is just a little bit too far over here, so I'm just going to back it a wee bit. There. There we go. Now if we look over at this side, uh-oh. A little bit of trouble using the camera, but I can see with my own eyes that this first one is in quite a bit. Not so much here. This is lined up pretty much dead on. Just tweak it a touch. Yeah, it's not quite all the way here, but it looks fine over here. So there's a bit of a non-linearity in the overall sweep, which is what I was trying to see earlier, but I couldn't. So sometimes when the screen is just traveling, it's quite obvious, like looking at an old TV with the linearity out, where the picture is ballooning at the top or something like that was happening over here. See, it's a little shaky over here too. That's a curious thing. Let me just adjust the trigger level here and see if I can settle that down. Oh yeah, there we go. Okay, checking again, lined up, lined up. That's good. Okay, so that's it for that particular frequency, or that particular adjustment. The next one is, okay, I'm going to read up on the next one and set up for that. Okay, the next one is the times 10 gain. So what I've done is I've set this to 1/10 of the frequency it was before. It's 100 hertz, in fact. And we'll pull on the times 10 here. Well, that kind of went the wrong way, didn't it? Okay, let's go the other way here. Up, up. Okay, so now we are set to 10 kilohertz. Let me just make this absolutely precise. Tricky to do. There we are. Okay. Now, again, why is it this has become dotted again? So this is out, but still on calibrate. And all we got to do is exactly the same thing we did before. So let's take a look here. curious about why this is so dashed line. Maybe it's the signal generator doing that. Okay, so first we're going to line one of these up dead center. Oh, it's on times 10, so there's a huge amount here. So pick any one, line it right up. There we are. Okay, look over here. It's coming up a little bit. Oh, this didn't work out. This is not going every... Oh, is that because this is so bad? Yeah, I think so. Okay, let's try adjusting. There we go. Adjusting. Well, you know what? That's maximum adjustment there. Frequency is 10 kilohertz. That's maximum adjustment. It's a little out over here. Times 10. I don't use the times 10 anything. Anyway, so good. Okay, what's next on the hit parade here? The next calibration step is done at 1 microsecond, which is the same as 100,000 hertz. 100,000 hertz, yeah. And this is what we're adjusting. This little capacitor here, which you can see right here. Centering it, and I'll try the adjustment again. And I'm using too small of a screwdriver here. I need one that gives me a little more control. That's too big. This will be good. This will do the trick. Okay, now no effect from the screwdriver. Here we go. Now see, it just jumps. Just turning the capacitor around and around now to maybe improve. Maybe there's a contact problem in there. Looks like maybe it's... Oh, it just jumped again. Uh-oh. Okay, I'll center it up. Way off. This one's tough. Center it up. Just seems I want to be in two positions, one or the other. So I'm going to leave it like this. That's me turning it up brightness-wise. Okay, didn't go great, but we are talking about 100,000 hertz on my scope. Okay, I'll check on the next thing.